This video will briefly introduce a low-profile broadband dual-polarization double-layer metasurface antenna for 2G, 3G and LTE cellular base stations. The relevant work can be found in IEEE transactions on antennas and propagation. The cross-polarized dipole antennas, majorly employed in mobile communication systems, use complicated feeding mechanism and structural modifications to meet the performance requirements. They also usually occupy a profile of quarter wavelength for unidirectional radiation pattern. Recently, introduction of metasurfaces in antenna design helps in realizing low-profile antenna, with the possibility to widen the bandwidth using surface wave resonance. Such a single-layer metasurface requires larger aperture size to realize wideband operation and in turn needs a larger reflector, which results in practical challenges. The low efficiency and limited interaction of the incident field with scatterers in a single-layer surface imposes difficulties and demands multi-layer structures. In this paper, an ultra-thin double-layer metasurface with optimized interlayer coupling is combined with a cross-dipole antenna. The reactive coupling of higher-order Foucault modes aids in the miniaturization of the metasurface. Operating the metasurface in the non-resonant region facilitates wideband phase compensation and encompasses the resonant frequencies of a conventional cross-dipole antenna despite the reduced profile. In addition, T-surface waves propagating in the orthogonal direction to the excited dipole and radiating at the ends is observed at the higher frequency band. This resonance is controlled by the metasurface dimension. A dual-polarized, double-layer metasurface antenna is fabricated to validate the proposed concept. The antenna with a profile of 0.15 lambda covers the target band of 1.71 to 2.69 GHz with isolation greater than 27 decibels. The average realized bore site gain is 9 dB with a plus or minus 1 decibel variation. The half power beam width is 56 plus or minus 12 degrees in H and V plane. The radiation patterns show cross-polarization level less than minus 18 decibels, front-to-back ratio and side lobe level higher than 16.8 decibels. The simulated radiation efficiency is above 86%. To conclude, the proposed dual-polarized antenna incorporates double-layer metasurface to miniaturize the metasurface size and enhance design flexibility. In comparison to the conventional dipole antennas with a profile of 0.25 lambda, the overall profile of this antenna is reduced to 0.15 lambda. The bandwidth covers the 2G, 3G and LTE bands. More details of this work can be found in the reference. Thank you for your attention.